Good afternoon, everyone, and welcome to today's webinar hosted by GlobalLogix. Our webinar today is entitled SCADA and IoT. Are you ready? We are very glad that you've joined us, and it looks like we've got a great crowd, so let's get started. First, let's start off with our agenda for today. We're going to cover some ground rules. I'm going to give you an introduction of today's presenter. And listen, we want you to participate, so get ready to send us your questions. We're going to have our presentation and then a live question and answer session at the end. Our ground rules are very simple. We've got everybody's audio muted today so that we can have a clean broadcast, which we will then be posting and sending out to everybody who registered for the webinar. We do want you to participate though, so please send us your questions via the question panel here in GoToWebinar. Next, let me introduce you to our presenter today. He is Charles J. Drobny Jr., or you can call him Chuck. He's the president and CEO of GlobalLogix. You can read a little bit about Chuck on the screen, but he's an expert in midstream oil and gas, industrial automation, SCADA, and the Internet of Things. So without further ado, I'm going to pass it off to Chuck.
Hey, good afternoon, everybody. Thanks for attending. I think we have some more participants than we had last time, and that's gratifying. I want to talk today about the Internet of Things in oil and gas, and ask the question, are we ready, or are you ready? I will tell you that there's nothing more pressing in the IT circles in the last year than this concept of the Internet of Things. It's all over all the publications. It's frequently discussed in a lot of IT circles. And that is also very, very true in midstream oil and gas. I believe that there are a lot of obstacles standing in the way of the implementation of the Internet of Things in oil and gas, particularly in midstream. And today I want to cover the 6 reasons why I believe that the Internet of Things is a long way off for us. After that, discussing each one of those in detail, what I'll do is give you my recommendation on how to overcome those barriers and how I think that oil and gas operators, midstream particularly, can overcome those barriers. So we'll start off by giving you the list of the 6 items. You'll see them on the screen. And then we're going to go back in and cover each. So to define the scope of what we're going to talk about today, first issue is there's too many disparate devices out in midstream oil and gas. There are too many software protocols amongst all of those various IoT devices that are out in the field. The next item we'll cover is that the efficiencies that companies say that they want to achieve are not defined, and they're certainly not known and uniform across the organizations. The algorithms that companies believe will be used to crunch all this data and lead to definitive conclusions don't exist and need a lot of time to develop. That the cyber threat environment will continue to increase and intensify, and that will impact the implementation of IoT in midstream oil and gas. And then the final reason is the side benefit perceived about the Internet of Things with regards to preventing maintenance failures, i.e. predicting them beforehand, is not operationally and culturally supported the way the industry is organized and companies are run these days. So we've got those 6 items. Let's talk about number 1. Too many disparate devices. Let's start off with a couple of examples of numbers and start to look at how the math for the number of data points that have to be considered for the Internet of Things rapidly expands almost logarithmically. There's maybe 1 million wells in the United States, give or take. Most of those are inactive. And maybe there's somewhere, I've heard numbers as high as 100,000, but let's assume we're only talking about 25,000 revenue producing oil wells in the United States. And then let's look at that and say maybe 10,000 of those have been built in the last 5 years, and they contain contemporary equipment, modern stuff. Okay, so let's look at what goes on in these things. All right, if we look at sensor points on a well, there may be 50 sensor points. You might want to write that number down. On a gathering system, there may be 100 hardware sensor points compressor station, maybe 100, 150. A pipeline or a river crossing or a pump station, maybe another 100. So we start out right away with something like 25,000 or 50,000 wells, and then we start looking at parts of those, and we start looking at numbers times 100 times 150. That math gets big. But wait a second, it gets even bigger. Each one of those hardware data points may generate software data points inside the systems for various control processes that anywhere's up to 20 per sensor point. So we start taking numbers like 25,000 times 100 times 20. It's no doubt that the universe for the Internet of Things data points rapidly gets into the millions. It's a lot of data points out there, a lot more than anybody even envisions to get their hands around. Now, if all of those systems were built the same and all of them were managed the same, maybe that could possibly be manageable. But let's add to the complexity. There's thousands of legacy systems out there, well pads, gathering systems, compressor station, and pipelines. And those legacy systems are in some really different kinds of shape. So we do the math again, we work it out. Let's say we're talking about 2.5 million internet source points on new wells, maybe 975,000 with old wells with no source points. We're dealing in tens of thousands. Now, okay, you say, well, look, not every company operates out there, and my company only has 1,500 wells in this field. Okay, cut the numbers down. We're not dealing, knock one or two zeros off. You still have a significantly complex problem with regards to how you get all these data points into one place so you can analyze them. Now that assumes that everything's static. But what do we see in the marketplace? Let's assume that every field that's out there is nicely configured and it's peculiar for that company and it's working well. Look at the newspaper, look at the financial press. Every month here in Houston, we read about one company that's buying a field from another company. One company wants to get out of the Bakken, get more concentrated in the Eagle Ford, or go from one part of the Permian Basin to another, one play to another. These are happening sometimes 3 or 4 a month. And what happens is these things are discovered, oil wells are discovered, developed, and drilled by a single owner. He develops his field and he turns around and he sells it. When that field is sold, I'll tell you that I don't think that the type or the condition of the SCADA system has any relevance in determining the price of the field. So the key element for the Internet of Things is getting changed constantly. Purchased systems, we find, don't get reworked. The assumption is that there's a SCADA system. One SCADA system looks just like another SCADA system. We'll just plug them together. There's a lot of mismatched SCADA systems out there, and I'll explain to you in the next slide why. Okay, first of all, the older systems don't look as robust as the newer systems. Older systems have far fewer data points. The data collection protocols don't normalize the data. You have some older systems that report data in non-synchronous time periods or different or variable time periods. So the idea of trying to normalize the data amongst the old systems is even more complicated than taking two disparate new systems and trying to put them together. Back when we built old systems, we knew that bandwidth to send stuff wirelessly was very, very hard to come by, and it was very expensive. So we purposely designed those systems and put them in place so that they weren't sending all those huge, robust amounts of data. We know that the Internet of Things calls for very, very robust packets of data, reams and reams or gobs and gobs of data, but the older systems weren't designed. So a lot of the systems that are out there are just not sufficiently robust to meet the Internet of Things vision. In addition, the older systems, a lot of them are broken. When we go out and we survey existing systems for customers, we find that it's very common that there are a lot of data points and sensor points that are only partially working. They think that they're reporting data, but they're reporting constants. They're not reporting variables, or stuff is just simply disconnected and not working. The well is producing, the company is managing the property, but all the data points aren't up and running properly. How do you connect them? Well, first of all, we don't even know, and no company, I postulate here that no company knows exactly what they have in every one of those physical facilities, in every one of those data collection points, in every one of those data gathering systems. There are, they don't know the nomenclature, they don't know the type, they don't know the software version. So trying to turn around and normalize these data streams when you don't even know what's producing it is kind of tough. It's kind of like going to the parts store and going to order a starter for the car, but you have no idea what kind of car you have. You can't do it. A lot of the older systems are broken. They're obsolete. Now they're functional, they're working, they're producing product, but they're obsolete. They're obsolete, but yet they're functional. So the problem is complex not only with equity transfer, the new owner has a completely different system to integrate. That's not even in good shape. Now, you think it's easy from that standpoint. We have another problem to add even further to that complexity. There are too many software protocols. We operate in an environment in offices and with our business software where it's either a Mac or it's a Windows system. And even those systems talk to each other and communicate various data formats pretty seamlessly. We use our handheld devices, our smartphones, and we have either an Apple system or an Android system. And those systems are finding a way to get together. It gets a little complicated with Mac Windows, Apple Android. Well, think about that and logarithmically increase the probability of trying to get by with dozens and dozens of different protocols, because that's what we have in the software protocols between the PLCs and the RTUs. There's a huge mismatch of software, and there's also a huge mismatch of compatibility versions. The SCADA systems for different companies and even in parts of their fields, particularly where their new holdings are a combination of their legacy holdings plus some holdings that were acquired in a large M&A purchase. The data formats are inconsistent, and the data systems are not gathered at the same pace with the same normalization. So we have a huge population of devices, a huge population of software protocols and versions, and the assumption that all these data points, because they're being reported in some way, can suddenly just be gathered into one large computer and then applied to algorithms to achieve what we want out of the Internet of Things is just impractical. It's not going to happen. Let's talk about the efficiencies that companies say they want to get out of using the Internet of Things. We hear constantly, if we take this huge volume of data, and here we assume that we can get the data out of the oil patch, that we normalize it, we crunch it through algorithms, that can then tell us how to operate more efficiently. Well, in my experience, and our experience here at GlobalLogix, we ask people in operating companies to define the term efficiency. What is it that you're trying to achieve? How would you know how to change your operation? Are you looking for more barrels per day, more barrels per hour? Are you looking for a percentage of downtime? You know, what are those KPIs or those key indicators that if you manage them based upon what you learned from the IoT data, then your bottom line is going to be improved. Efficiency is a numerator divided by a denominator. It's quantitative. If you go to these companies and ask them to define efficiency, I dare say that you don't have two people answering in the same specific terms, yet the assumption for the Internet of Things is that we're going to become more efficient. Everybody accepts it, but nobody has yet defined it with uniformity so that it can be applied by a team trying to implement the Internet of Things. That's not such a bad indictment, particularly when you consider that markets are constantly changing. So a company that has a set of goals and objectives, that may be based upon a specific market price for the day. Well, we're in an environment where marketplace pricing, demand requirements, supply availability are in constant flux. We're constantly moving price around, and that probably will change some of the desires for the efficiencies. In addition, we're constantly changing managerial and technical positions. We run through an up or a down slope in oil and gas. We have declining profitability because we have declining revenue. We do massive layoffs. We reduce staff. We reassign people. And you wind up with trying to implement something like the Internet of Things, which may reasonably on an 18 to 36-month timeline. But during that timeline, you're constantly shuffling and changing your people around. Very difficult. So I ask the question of people all the time, okay, you're going to apply these algorithms, these sophisticated mathematical formulas that crunch massive amounts of data to determine patterns that are not discernible through normal observation, but through the Internet of Things and through the application of the algorithm, you believe that you'll be able to make those conclusions. Well, where are those algorithms? How are they worked? These algorithms are going to have to be developed over time, trial and error, hypothesize on what the algorithm should produce, take a look at what the results are, go back and recheck your data, make your operational change and see if it has an effect. These things take time, but we don't even have the algorithms to start out with. So that's another barrier. Now, change gears a little bit and think about the cyber threat. Cyber is probably the second most talked about topic amongst the IT people in oil and gas. We just suffered a global near meltdown of a cyber threat in hospitals and some 139 different countries, transportation systems. We know that the cyber landscape is increasing and it's not going to get any smaller. The first line of defense in cybersecurity is to know what you have and know where it is, which means some sort of catalog of the components with a valid registry of your end devices. We have yet to see a company that knows where their end devices specifically are, what the nomenclature is, what the model number is, what the software version is, what the configuration is, and how it's been updated. This is the first step in maintaining consistency of data. It's also a first step in maintaining cybersecurity. We don't have that. Add to that complication, unlike systems that are in offices behind locked doors with pretty decent password administration and password control, if we go out into the oil patch and we look at the RTUs and the PLCs and the control systems that are out in the field, pretty much 90% of those control systems have password protection. And the password is admin and the login is admin. Pretty much anybody can go out in the field and make changes to some of the devices or most of the devices that are recording data and reporting that data in the oil patch. Now, one of the things that the Internet of Things promises, besides improving operational efficiency, is this question of being able to predict maintenance failure. Now, they'll argue that if you have massive amounts of data coming off of, say, a compressor station, and you constantly churn this data and assume that you have the algorithm, assume that you have the data, you should be able to predict when that compressor or that major piece of equipment is going to fail. The idea being that the numbers will subtly tell you over a course of time that they have a pattern that's predicting an imminent failure. Well, if you go into the culture in the oil patch, and this is true of most industrial organizations that I've seen, where the maintenance manager goes to the operations manager and says, look, my data analysis is clear. I really believe that it's pointing to an imminent failure of this major component. And what we need to do is we need to take it out of service. We need to take it out of service now so we can repair it and put it back online, because if we do it, the maintenance can be planned, it can be a lot less expensive and a lot less disruptive. If we have a catastrophic failure, we're going to have operational issues, we're going to have a lot higher cost to go out on an emergency pants on fire exercise to change out this major piece of equipment, this compressor, this transfer station. That culture doesn't exist, and I really don't think that the Internet of Things promise of maintaining equipment before it fails is ever going to materialize, and particularly I can't see it materializing in oil and gas, in midstream. I think that may work well perhaps in a refinery, and it may work well with a drill rig, but these are not continuous. Well, one's a continuous operation and the other one isn't. I don't think it's going to happen. So we've identified, the 6 reasons why I think implementing IoT in midstream oil and gas is going to be difficult. What do I propose as an alternative? The concept of analyzing algorithmically large amounts of consistent normalized data is totally valid. And I believe that we don't even know now what this will do for us in the future. Do I think it will happen? Eventually, yes. Do I think it's the wave of the future? Absolutely. But how do we do it? Well, the way to start out is I follow one of the concepts that says sometimes people, when they're developing technology, don't know what they want until after they get it. So what an organization has to do is it has to look and say, how is this Internet of Things going to be implemented, and how is it going to work for our organization? We deal with 105 different companies, and every one of those companies operates differently. They all move gas, they all move oil, they all dispose of water. They all have similar kinds of functions in the field, but there isn't one of those companies that's organized the same way as another company. They're all different. There's tens of thousands of wells out there, and we've gone out there and we haven't seen 2 of them that are exactly alike. There's a lot of differences out there. So what do? My proposal is that a company looks and says, let's start off with a prototype application, and let's limit the scope of what this prototype is going to be. If you try to take IoT and implement it enterprise-wide, you'll never get to first base. So select an operational unit that's manageable. Let's say you have a field that you've drilled and you've developed, and there's 150 wells on it, and those wells have been padded up, and the gathering systems have been connected, and this field has been in production for a year. Everything seems to be working well. The equipment that's installed is generally the same kinds of equipment, the same brands. There's consistency amongst the data. The network operations center sees the data and operates well. And this is kind of like the, you have a fleet of trucks and you have a new truck that's only about 6 months old. That's the one that you know how to use. It's maybe the last 5 vehicles and they're all alike. Just pick those. Pick the ones you know, pick the ones that are new, limit the scope. Now, management's got to turn around and identify the business problem that they're trying to solve with the Internet of Things. And all I've got to do is state what it is. Our goal in this field is to produce the maximum number of barrels per day possible over the course of a 6-month time period. That's a reasonable statement. Or perhaps our goal is to produce this well so that our wastewater is always hauled within 2 hours of filling the tank, and that every truck that goes to siphon off and dispose of wastewater goes out empty and comes back 100% full. That's our definition of efficiency. We know that if we do our water retrieval that way, we will be more efficient and we will save money. So define the business problem, okay? Then you've got to turn around and validate the SCADA system's integrity. Go back through all of your data points, all of your source devices, and make sure that you've got good system integrity with your data. Normalize your data format, which probably is if your control center is seeing this data in this small subsystem. And then validate the integrity of the server. Now, the next step is develop an algorithm that sifts through the data and gives you some sort of performance parameter that points toward your business objective. Run it and compare your results. Again, remember, you're using a geographically contained field. You're using a field that has somewhat modern or totally modern equipment in it. It's recent, it works, it's in good shape, you validated it. Now you run the Internet of Things on a small scale and make adjustments to your algorithm and make adjustments to your data collection. From that, I guarantee that you'll discover the issues that, number one, produce benefits for you. It'll also tell you the issues that you have that'll make it difficult for you to get the whole system employed. More important than identifying your problems is identifying what the benefits are going to be and how those benefits will pay off. Now, what about the big IoT problem? Let's suppose that you've done the prototype system, you've done it on a small limited area, you've run it for a year and a half, maybe 2 years, you have some good solid operational results, and you're convinced that this is going to work. Now you look and say, let's start rolling it out to other parts of our operation. You're going to get to the point where the normal collection on a lily pad basis of going from one point to the next, finally landing on a server, getting processed on that server and then distributed, is not going to work. The big IoT question for a large enterprise has to go to the cloud. It has to go up to the cloud from the end devices. It has to go up to the cloud from the servers. The cloud needs to be the gathering point for all this data. Only the cloud's capable of doing it, because you can't maintain these systems on a connected basis from A to B to C to D. Everything's got to go up to the cloud, come back down where it needs to go. We have people who envision a technician going to a site and looking at the performance data for their SCADA system on their iPad. And the thought is, well, what we should do is we should be able to connect the iPad through Wi-Fi or Bluetooth to the device so that the technician can read it right there on his iPad. The thought is that maybe even send that data to a server someplace where they can read it in another location, like the control center. Well, I think that's a valid concept for what you want to do operationally, but you can't send the data from the device to the iPad. You want to send the data to the device up to the cloud, and then from the cloud back down to the iPad. It may look like standing next to the device that I'm reading that device directly from that device, but really what I'm doing is I'm reading from the cloud, the device is sending to the cloud. Now the ramification is clear. I don't have to be standing next to the device to see how it performs. I could be at my kitchen table, or I could be in my office, or I could be in a truck parked next to another device on the other side of the county, when maybe I get an alert on my laptop or on my iPad or on my iPhone that says, take a look at this device 20 miles away. So my conclusions with the Internet of Things in oil and gas is that it's a valid concept, but folks, I think it's a long way off. I think we've got to start with a modern system that's most likely to have similar devices, similar firmware, similar data formats. We need to limit the development platform, build the algorithms, avoid the maintenance failure trap, and go to the cloud quickly, but prove locally. The concept is wise. It's difficult in oil and gas. We have tens of thousands of facilities and devices. You have these devices spread over some of the most inhospitable areas in the country. It's not like you're trying to do the Internet of Things off of a factory that never moves, or even off of a pipeline that's always just in one place. There are a lot of operational problems that we face. We've identified some of them. I hope this has been interesting for you guys. I'm more than happy to take questions or listen to your comments or your input. I do value those questions and those comments. So I'll open up the floor.
All right, thanks, Chuck. That was fantastic. Very, very informative, and we do have some questions lined up. I do want to tell everybody in attendance today, which is a pretty good crowd here, that if you have questions that you'd like Chuck to answer about the Internet of Things in midstream oil and gas, please submit those in the question panel here and go to webinar. So Chuck, our first question, I think it's kind of a starting out question, is can you define IoT? It seems like an extremely broad topic.
Yeah, it's a broad topic, and I think everybody has their own perception of it, and that perception is usually based upon their viewpoint and what they're doing and how they're doing it. But to answer your question, the Internet of Things is a broad collection of different types of sensor inputs or machine inputs that ordinarily are monitored singly, that are multiplexed together and then analyzed in depth to produce conclusions so that systems can be changed electrically or mechanically to produce different results. Now, that may mean you can use your cell phone to change the temperature in your house, or your refrigerator may tell you when you need more milk, or an oil field may tell you that the output on adjacent wells has started to change, and that historically is going to change the output on another proximate well, and thus change the amount of wastewater that gets filled. And you need to look in the next 5 or 6 days at changing your truck schedule so that you don't shut in your well because your truck needs to go empty the water.
Okay, hopefully that answered the question for that person who asked it. Our next question, Chuck, is how do we fix the problem you described about efficiencies inside of our companies?
Well, that's a high-level management issue. It's got to come from the corner office. Frankly, I don't know that it's ever really going to change on a massive scale. It may change with some managers on a local level. Typically, smaller companies and smaller organizations can do that. Inside of large oil companies where different departments are siloed, each silo may be able to define those efficiencies. But quite frankly, I don't really see the cultural environment right now that says this is exactly the parameter that we're going to shoot for. This is the key indicator that we're going to use to change. You know, all these sophisticated enterprise-wide managerial systems all talk about these KPIs, and every one of these systems advertises that when they're implemented enterprise-wide, the executives in the corner office are going to be able to have a console or a panel, some sort of screenshot that shows all the key indicators in the company. Well, in 40 years, or in the last 10 or 20 years, as these systems supposedly come about, I've never walked in anybody's office and seen a panel up on a screen. I don't think that they're present. Occasionally, we'll see somebody with a chart or a graph on the wall. You know, we look at things like 12-month trailing totals. We look at things like utilization. We graph them and put them up on the wall. We're a small company. We're pursuing that, but I don't see it in the large companies.
Do you think that that's companies that are doing that is an indication of their sophistication or success in their industries, or is that really not happening anywhere?
It's tough to use the term sophistication because it's compared to what, and then it kind of becomes pejorative if I'm telling somebody that he's not sophisticated. I think it's a managerial style, and it's a leadership issue based upon the way things are being led. Smaller companies tend to be run by the people who control the equity position in the company, as opposed to large companies that are owned by large blocks of shareholders in different organizations. And they're really looking at their fiduciary responsibility and they don't act as like owners like small companies do.
Gotcha. We've had an attendee ask, what do you read and follow regarding the Internet of Things as a topic?
I don't pursue a particular set. I have, I don't know, like everybody else out there, I probably get 300 or 400 emails a day, most of which wind up in the spam filter. I get a lot of contemporary articles about oil and gas. There's some blogs that are out there. Whenever I see an article or something about the Internet of Things, along with some other topics too that I zero in on, I'll drill down and read the article. But I don't find that there's any one particular blog post or media source that has all the answers. There are some companies out there that I like what they're doing and what they're saying. I like their approach, and I'll keep up on social media, and whenever they publish something new, I'll take a look at it.
Okay, great. Our next question, it says, it seems like there are a lot of software companies that have their own version of IoT. Who should I pay attention to?
Well, I would say pick one based upon trust and relationship. Find a company that has a solution that encompasses the scope of your enterprise. Identify the people in the company who you trust them, both from a business standpoint and a technical standpoint. Work with them and stick with them. This whole idea of every step of the way, creating some specification for something that you don't know, asking for bids, and then apparently picking the best bid, which really means the lowest number, is just rife with problems. Pick a partner, get that partner committed. You commit to that partner and work with them on a stepwise basis. Keep the same project manager in place. So rather than say, which one should I pick? My answer to that is a little evasive. It says, pick one, O-N-E, and stick with that one.
Okay, great. Another attendee asks, is there another industry that is putting an emphasis on IoT like energy?
Well, I think energy is putting a lot of, giving a lot of lip service and a lot of press. I don't know how much work they're doing compared to some others. Probably the one that I think leads, in my mind, is municipal electricity. These guys have a lot of devices that they're putting out amongst their customers. These devices have to be out there so they can collect their money. And the user devices that you see next to your house or next to your factory, both for electricity and for water, in my mind, are more advanced than the ones that we're looking at trying to do in oil and gas. I think that refineries are way ahead of the game, way ahead of the midstream segment, and the new drill platforms and the new transportable rigs are way ahead of the game over midstream oil and gas. If I were to look to see who has a better leg up on it, I would look at companies with facilities that have continuous processes that are in a location that works, that's modern in, say, the last 4 or 5 years, and has been constructed with the idea of minimizing the number of operational people who are turning valves and pushing buttons and adjusting levels, because those functions are being accomplished by machines. Those are the ones that I look at. Some new food processing plants that are very advanced. There's some new chemical facilities that are very advanced. And my guess is those folks are way ahead of us in terms of pursuing IoT.
Okay, great. We've had some more questions come in. I would definitely like to let everybody know if you've got a question you'd like Chuck to answer, go ahead and send them in now. We're going to go to one that was just sent in. It's pretty long, Chuck, so bear with me here for a minute. So it was Mike Rogers sent this in. He said, what do you see the role of that first cloud stop on the IoT SCADA coming in from the field? Is it universal data translator, parentheses, manage ongoing APIs and data protocols? Is it also the data aggregator? Does it have a role as the historian and analytics engine, or is that downstream?
I think that the best answer to A, B, or C is yes. My vision is that there have to be some aggregated end devices put in place that can make the linkage up into the cloud. We have, if you figure that let's just say there's 50 different software versions where the data has to be transformed with some sort of API. Those APIs, if you try to put them out in the field, you're putting them out in thousands of different places. Instead, take the data from the end device on the cloud, do the transformation in the cloud by selecting that API, and then feed the data normally as you do to your existing servers. And I think that the analytics, or the algorithmic application to the analytics, should be done on a server that's up in the cloud, but that's being fed by the present data collection servers that are there for normal SCADA.
Great, that's awesome. Mike also did contribute and mentioned, wanted to mention that he said medical is doing a lot in the IoT space, including his company. So throw that out there as well for everybody. Next question is, do you see any application of IoT used in any level of government currently?
Let me backtrack to the comment about the medical and what Mike's folks are doing. I think the biggest barrier for the medical people are the confusing mismatch of HIPAA rules that determine how certain data about certain patients can and can't be used. They have a real hard task with government, and we all have a problem with government regulations changing and being unsure. But the medical has this HIPAA requirement that makes it even doubly complicated. All right, now what was the question that you just asked?
No problem. The question was, do you see any application of IoT being used in any level of government currently?
I would love to see IoT applied to simple urban traffic control systems, traffic lights, gateways to get on and off freeways. Take a look at how traffic flows are impacted, so that if there are accidents, lights can be changed for synchronization, traffic can flow smoother. You know, we talk about efficiencies or how we can get more output out of less input. Probably the biggest inefficiency that we all see on a daily basis is people spending time in vehicles trying to get someplace when 10,000 people can be held up by one driver or one incident that could be avoided by rerouting traffic around it. So my first start on the government side is to do it with municipal traffic control. That's off the top of my head. That was a good question.
Great. Okay, so another question has come in from Penny. She asks, what are your thoughts on SCADA and IoT in fields that are located where phone and internet service is less than desirable?
You know, that's a big problem that we have now in some areas. Years ago, satellite was the only way to get to it. The ubiquity of a lot of the newer cell phone service providers and the interconnectivity is getting better. One of the things that people don't realize in the US is that our telephony system, which essentially created and formed the backbone of our internet system. You know, we went from telephony, which was analog, into digital internet and phone. We're carrying phone signals over the same wires. Most of our infrastructure was built for telephony. Most of the rest of the world was built for digital and built wirelessly. So in a lot of places in remote areas, we have less connectivity in the US than some countries, some so-called third world countries have. SCADA can function well in a controlled environment locally if you want to be able to monitor that control system remotely. You've got to have some sort of data transfer capability, whether it's not feasible to make it hardwired, but we just have to continue to build out. You know, when we built out the Eagleford in the last several years, that area of Texas was virtually uncovered with wireless. There was some, it was not very well connected. 3 or 4 years later, because of the advent of all that oil and gas production, that area of the state is much better connected now. So, you know, the money drives it. If you get an area that has a lot of oil and gas in it, and that oil and gas is going to be produced and profitable, you're going to see the wireless capability improved by the wireless service providers. So they go hand in hand. SCADA has to start first locally, then you can use it to control it from a control center. And then as the bandwidth comes up, you're going to be able to use that increased bandwidth to carry those higher data rates to use the Internet of Things effectively.
Okay, this is an interesting question, and something I've actually wondered about as well. Attendee asked, said, I do see a lot of talk about IoT. Where is it making an impact now?
Well, it's making an impact now on the ability to control disparate devices with single control systems in buildings and in residential facilities. I mean, I can control the temperature in my house remotely with my phone. I can check to see if my wife's home and what she's doing by looking to see if her car's in the garage, and then looking to see if she's cooking dinner in the kitchen. When I get off an airplane after a trip, we can turn the air conditioning back down. Using the phone, I can turn the lights on and off. I can control the TV. So there's probably more Internet of Things connectivity there. My thermostat actually looks at the ambient temperature in the house and actually looks to see if there's people moving around, and controls the temperature, brings it up or brings it down, so that I'm not spending money on electricity when I'm not home. So the most of the activity that I see is in the home. However, when you build new buildings, you build new factories, there's a lot more data gathering capability installed. There are a lot more endpoints installed, and particularly the conduits or the circuitry needed to interconnect these things, whether there's fiber run through the factory or there's wireless run through the factory. Those things are being designed up front with substantially larger capacities to handle substantially greater streams of data, so that these kinds of futuristic systems, characterized by this broadly defined term, the Internet of Things, can in fact be implemented. And when I say greater, I'm not thinking about double or triple. I'm always thinking about an exponential increase, power of 10 at least.
So we're really still in the early adopter stages in terms of the impact of IoT on industry, various industries. Is that fair to say?
It's fair to say it's early in the game. You know, in hindsight, we have to look back. The thing that we realize is that the pace of change and development for digital technology continues to accelerate by pace. This kind of statement freaks a lot of people out because they're fearful that everybody's going to get passed up. The human brain is capable of handling so much more than what we have. What these digital tools are giving us is better tools, better mechanisms, and yeah, I think it's safe to say. I mean, I look back in my lifetime. Started out with black and white TV sets. FM was a new radio. I had a rotary dial telephone, and the device that I use, my Apple Watch, does things that only Dick Tracy was doing on his wrist in the comic books. So yeah, I think I don't know if we're early or late, but we're going to continue to see that 10x improvement in technology in shorter time periods. There are some technologies that are widely accepted now that are only a few years old. I mean, the iPhone or the smartphone isn't very old. I don't even think it's 10 years old. So the pace is quickened, and we're going to continue to do that, continue to do things. I mean, look at something as simple as walking through a door. That's essentially a SCADA control system that looks to see if somebody's walking toward the doorway, and it actuates a motor that opens up the door. I mean, that was Flash Gordon, and that was Star Trek. People walking up the doors and they automatically open for them. Well, gee whiz, I can't remember the last time I walked into a grocery store or a retail establishment and I had to open up the door by myself. So the pace is quick, and yeah, we're in the early stage.
Okay, we've got one more question, unless anybody's got one they want to submit real quick. So our last question says, I don't see any of the large tech companies discussing IoT like Google, Apple, Tesla, or Microsoft. Why do you think that is?
Oh, I think the large industrial processing companies, you know, whether it's the you know, Siemens or ABB or Schneider. Those guys are talking about it a lot. If you look at what they're doing, in addition, the GE talks about it. GE's been dealing with it a long time. That may have to do more with our exposure to the media, which for the most part, addresses the retail markets and the consumer markets. But I think that companies that are selling devices and designing and making new devices at all levels, whether it's large industrial all the way down to individual retail, are all looking at this concept and building. I don't have the numbers in front of me, but when you start to look at the number of interconnected digital devices that are in the world, it goes up by a power of 10, like every 6 months. Just an amazing amount of data that's out there.
All right, fantastic. Well, we didn't have any more questions come in, and we are getting close to the top of the hour. So, Chuck, once again, thank you for that presentation. It was fantastic. And thank you to everybody who attended and stuck around with us for almost an entire hour. We really appreciate it. You'll be getting an email with a link to the recording of this webinar. And once again, have a great day, and thanks for joining us.
Bye now.